That's okay. Well, thank you for everyone for joining us for the September DataWorks Maryland meetup. Really excited to have two speakers from the Maryland area, Ellen from Protenus and Shelly from Yet Analytics. And what's exciting about this one is we actually work with TEDCO, which is a local organization that helps entrepreneurs and businesses. So both Shelly and Ellen are going to talk about some of the work that they're doing, which is related to building data products and data companies. Before we get started, I'd like just to go over our sponsors real quick and just go over some logistics. One second. It's not. Hold on one second. Okay, so Variant Technologies is a small government contracting company that's been supporting the meetup for several years. They do a lot of software engineering and data science work in the area. If you're interested in learning more about what they're working on, please reach out to me and I can make an introduction. Clarity Business Solutions is another software engineering, data science, and analytic company supporting defense contracting. If you're interested in learning more about what they're doing, please reach out to me. They also run the local Mongo meetup group, and they've also done some work with the local Elastic group, if you're interested in learning more about that. For some reason, my slides are acting up. ClearEdge is another defense contracting company that's doing data science. They do a little more, I think, than defense contracting. So if you're interested in learning more about that company, please let me know. Oh, man. Sorry about this. There we go. Aries Ventures is my company. So we're a very small company. We also do defense contracting. There's a theme here, as you can tell. But if you'd like to learn more, you can reach out and I can talk to you more about the opportunities that we're looking at. And then, in October, we're having a speaker from ESRI talking about GIS data. Pretty interesting, and how they're using their data with Python and doing different mapping applications. And then we're going to have a deep learning in healthcare talk. As always, we have a newsletter. We're working on a conference, and we're always looking for interesting speakers and sponsors. So if you're interested in any of those, please reach out. So with that, let me introduce the speaker. So Ellen is a neuroscientist. She's currently working at Protenus as the Director of Artificial Intelligence. And Shelly is the co-founder, president, and CEO of Yet Analytics. So what we're going to do is Shelly's going to speak first. And if you have any questions, I'm going to be monitoring the chats, both on YouTube and on Zoom. So just type in your question and I'll gather the question and I can ask either of them as we're going along. With that, I'm going to hand over to Ellen and you can share your screen.
All right. Let me just get set up real quickly. All right, Jason, does that look good? You can see the screen?
Yes.
Great, okay. So yeah, good evening, everybody. And thanks, Jason, for the invitation to come and speak with you all this evening. My name is Ellen Ambrose, and I'm the Director of AI at Protenus. Protenus is a Baltimore-based company. We were founded in 2014 by Robert Lord and Nick Culbertson. And what I'll talk to you about today is sort of the story of our trajectory of how we built our AI patient privacy product from scratch. So just to start, a little bit of background about our company. Protenus is a healthcare compliance analytics company. And what that means is we use data to identify workplace events which have the potential to cause harm to patients and to healthcare institutions. So I can unpack this definition a little bit. As everyone's probably aware, practically all aspects of the healthcare industry are required by state or federal law to comply with some type of regulations and policies, and healthcare institutions are required to enforce these policies in their workforce. So it can be really difficult to know how policies are being enforced, how well they're being enforced, and that's kind of where we come in. We can identify events or behaviors that could become problematic for the institution. And so in this way, we can help prevent harm to patients by ensuring patient safety and ensuring treatment quality, by identifying if there's employee behavior that might be negligent or unintentionally harmful or even malicious. And furthermore, we reduce harm to institutions by helping them protect their reputations, helping them increase the patient trust and confidence in the institution, and also helping them avoid some very steep fines that can be associated with failure to comply with some of these regulations. The problems that we solve specifically are in two areas. So our first module is around patient privacy monitoring, which is identifying employee behavior that could be in violation of HIPAA. HIPAA is a federal rule that governs the protection of personal health information, and it applies to any healthcare related institution or company, basically anyone that has this kind of data. And everyone listening has probably received some sort of notification about their rights and how their health data is being protected just when going to the doctor's office or having a hospital visit. And if any of you have ever worked in healthcare, you're probably very familiar with HIPAA because you've probably had to complete some pretty extensive trainings for your job to just ensure that you know what your policies, guidelines, and rules are. Hospitals take privacy very seriously, but it's really difficult to monitor for privacy violations, especially currently where data is just so available. Medical records are almost entirely electronic. So for patient safety reasons, a patient's record does need to be generally available to all of the providers and employees across an entire institution, but that also means that the potential for snooping is very high. So practically anyone that has access to an electronic medical system can access at least some part of every patient's record. So that's our first module, and that's what I'll talk about more today. But just to give you a little bit more of a taste of other problems we're working on, we also have a module for drug diversion surveillance. So this is analyzing employees' behaviors when they're handling controlled substances like opioids to try to detect employees who might have some sort of anomalous behavior and who might be diverting controlled substances. And diverting means basically just any behavior that could be described as transferring drugs away from the person for whom the drug was prescribed, whether it's for themselves or for any other illicit use. And in addition to detecting diversion specifically, we can also help identify employees whose handling and documentation of controlled substances fails to comply with institutional or federal policies, and these can lead to high fines for an institution. The outline for today's talk's in two parts. Part one, how we developed our privacy solution from just a handful of hypotheses into a full-fledged, sustainable, scalable AI solution. And then part two, how we use machine learning to prioritize the most suspicious employee behavior for our privacy compliance customers. From the beginning, Protenus had a strong vision for the commitment that we wanted to make to our customers. First, we wanted to ensure that we would evaluate all employee activity in patient records. And secondly, we would create cases for the most suspicious accesses to allow compliance teams to focus their attention and use their time most efficiently. So what I'm showing you here is just sort of an example of the raw data and what we want to do with it. On the far left is a table that is just sort of a little taste of what an audit log looks like from an electronic medical record system, where we have a number of employees, patients that they accessed, and a little bit of information about what they did in the record. So this is how every click in an electronic medical record is recorded. And this can be a really, really huge data set. This is on the order of tens to hundreds of millions of rows per day. And what we want to do is kind of go from that general activity to a ranked list of accesses, where I'm defining an access as basically all the activity between one employee and one patient on a day. And the vision that we sort of had was that we'll be able to rank this list. We'll have some sort of score for each of these accesses. And so we can rank them from most suspicious to least suspicious and just send the top cases to the customer for review. So the particular reason for these goals is really based on the needs of a privacy compliance team. Like I said, the raw data is so huge that it would really be impossible for even a team of compliance officers to review a significant proportion of this activity. And in a lot of cases, the office may be equipped to handle only a limited number of cases per week because they have a lot of follow-up that they have to do. They'll do employee interviews, patient notifications, and following up on any legal paperwork and legal matters if they need to. So that was sort of the vision, and this is what guided the evolution of our product and the particular solution that we ended up creating. So to start with, we had a very small company. There was one data scientist. We had a handful of example cases from an early customer. We had some hypotheses. We had hypotheses both about what are some features of an access that would make it more suspicious, and on the flip side, what are some features of an access that would make it less suspicious. And we also had, importantly, a network of compliance and healthcare professionals from early customers, from some outside advisors to the company. And then increasingly, we relied on hiring into our company people with this sort of background who are able to give us feedback on the quality of cases that we were generating. In the first implementation of the privacy application, we really employed just a very simple rules-based approach, which was essentially a decision tree, or you could also think of it sort of as a funnel, where we start with all of the accesses and we narrow them down to a much smaller set of potentially suspicious accesses, which were candidates to become privacy cases that would be investigated by the compliance teams in the hospital. So in this simplified example, I am just showing you an example of all data for one day and sort of how this data flow would look. We'd have start with all accesses, maybe around 400,000 per day. And we would apply some rules that would help us narrow them down. In this example, rule 1 is based on a simple hypothesis, which is that one reason an employee might violate patient privacy is because they want to find out some private health information or other personal information about someone that they know, for example, their coworker. And by applying some set of rules around identifying coworkers, we get down to about 200 accesses per day. And then rule 2 similarly contains a lot of different indicators that help us determine whether or not the employee is involved in the patient's care. So this could include rules like, is the patient being treated in the employee's department? Did the employee do some actions in the patient's record that indicate that they're involved in care? And after that point, maybe we have about 20 accesses that are still unexplained. And these are our potential cases. So we can actually get pretty far on these rules alone if this can take us from hundreds of thousands of accesses down to only 20 potentially suspicious coworker accesses on the day. But there's still a number of problems. This is still too many for the customers to review them all. This is sort of a binary output. We have a case or no case. And using it anytime you're really just using a rules-based system like this, you just give a lot of power to each rule. There's really no gray area. I'll just mention it here, but of course, at every stage, feedback is super, super important. So of course, feedback to make immediate improvements. So in this early system, this is like coming up with better rules, tuning these rules. But from the very beginning, we knew we wanted to be able to do machine learning. So we were also using this feedback to build ourselves a label data set. So for each access, we were starting to collect labels, suspicious or not suspicious. As time went on and we gathered more feedback and we got to learn more about the problem space, we started to get more sophisticated about the kinds of rules that we're using, even while still using the rule system. So we started to have more statistical and probability related rules. These are still rules, so we had to apply some sort of threshold based on empirical evidence. So for example, in this top plot, we might create the distribution of the proportion of adult patients accessed by employees in a given time range. And we could apply a threshold of mean minus 2.5 standard deviations and say that, any employee who's below this threshold would be unlikely to access patients over the age 18. And if they did so, we might consider this an outlier event. So that might be one type of activity or one hypothesis that we would look for. And then in the bottom example, we start to leverage our developing label data set. So here I'm showing a feature that's a z-score of a similarity index that we developed to measure how similar one employee is to other employees accessing the same patient. And the distribution of this feature on the positive data set is labeled in red, while the negative data set is labeled in blue. And so in this problem space, we never really see features that have really beautiful class separation, but we often find features that look something like this, where you can see that if we were to apply a threshold of 0 to this feature, we could eliminate a sizable proportion of the blue non-suspicious accesses while only losing a small proportion of suspicious accesses. So these are the sort of rules, sort of statistical-based rules that we began to incorporate, but even as we're using those rules, we're also kind of getting an idea of how they might contribute to a classifier in the future. This is just a more generic version of the rule-based approach. So we take the accesses, we identify a subset, which are outliers, and then we look to see what's left after we have then removed all of the accesses that we have some sort of potential explanation for. And at this point, we can also provide a score with each case, and you can imagine how we can kind of construct that from just sum of values associated with each rule, but it's not a very granular score. So by this point, we're starting to have enough label data to do some machine learning, and we want to use the classifier to fully leverage our feature set and generate a more granular score for ranking every access. But at this point, this is where we kind of ran into a technical roadblock with our approach. So our original application, as I've alluded to with this triangle, was implemented as a funnel. So we had to generate some features on all accesses. Features further down the funnel, we only had to generate on a smaller number of accesses, which greatly saved computing time and power. But to run a classifier on all accesses and really adhere to the original vision that we had set forth, we needed to be able to generate all features on all accesses. So what we ended up doing was a complete rewrite of our privacy application, this time leveraging Spark to allow us to parallelize complex feature generation. And so now what we're able to have is a data set that for every single access on the day, on the order of hundreds of thousands to maybe even a few million accesses, we have a number of features generated for every access. And now we can run all accesses through our classifier and assign each one case or no case. So even as we completed this version 2 of our privacy application, we still had a long way to go to complete the classifier. We started with a handful of features as classifier features that we knew were going to be promising, but they were not part of the original rule-based engine. However, all the logic in the rule-based engine at this point is not yet encompassed in the classifier, so we can't really do away with our rules just yet. When we first started running the production classifier as part of the application, the data flow looked like this. So we're still generating potential cases with the rules based on the rule-based approach. But previously, when we had this problem of how do you prioritize these cases, we can now rank those cases by a score that comes from the classifier, which I'll talk about more in the second part of the talk. And now we have this list of ranked cases. We can send the top requested number to the customer. So over time, we moved more and more of the rule logic into the classifier, and you can kind of see how the data flow is changing. But essentially, this whole process was just a kind of slow-ish process of taking these rules and incorporating them into the classifier score. So we didn't do this all in one go because we wanted to take some time to understand the impact of each feature or set of features, and because we had to put a process in place for going back and generating those features on our historical label data. But as we progressed, the data flow changed to rely less on the rules engine and more on the classifier until finally all of the rules had been integrated into the classifier as features. To summarize this process, this is just a little timeline of sort of what was happening in our product in terms of research and development. So in the development stages, we start with this rules-based case generation, but fairly on into that, we started thinking about how we can transition to version 2 of our application and started thinking about how we could change some of these rules into classifier features. And that led to a period where we had a hybrid case generation system as we worked to get all of the rules incorporated into the classifier and remove the reliance on the rule-based logic. And finally, we're able to fully transition into a classifier-based case generation. So simultaneously in research stages, research early on began as research to improve rules, just trying to get better cases to our customers. But even before we really started the kind of overhaul in the software development, we were already starting on research for improving the feature set and classifier performance. And then really importantly, this is something that there's no way we could have done without a pretty large label data set. And this is the kind of data that really requires expert review to put together. So it's not really something you can outsource. We started with label data set creation. So both in the cases that customers were reviewing for us, but earlier on, also relying heavily on our internal team to be able to review a large number of cases for us and sort of kickstart that data set. And over time, when we had enough of that historical label data set, we transitioned to a point where now we're able to continue building our label data set over time, just using the case resolutions that our customers come up with as they finish their case investigations. So that makes it really just a sort of sustainable system where we have constant feedback. To wrap up this section, I just want to mention that even though we've successfully created a classifier that's capable of scoring all the accesses in which we can use to prioritize cases, the work for improving and maintaining the system never really ends. So in particular, I'll just leave you with 2 questions just to puzzle over that are areas of ongoing research for us. So first, because we only send customers a few cases, the number of cases that they can handle, we send them the most suspicious cases, we only receive feedback on the most suspicious cases. So how does this, what does this mean for our label data set evolving over time when we don't get labels back on every access? And a second ongoing question is, how do we introduce new signals for suspicious activity that may or may not be present in our label data set? So we're always coming up with new features, new hypotheses about something that could make an access more suspicious, but because these are novel ideas, how do we go about testing them and getting feedback when they are accesses that might not have high scores with our current classifier?
Hey, so Ellen, can I ask a question or two?
Yeah, absolutely.
So I had a question. I was trying to understand. So you have different customers, right? And I guess each customer has its own way of managing health records. I'm not that familiar with the space. So with the label data set, is that specific to each customer, or do you just have like a global data set? And then like the follow on that question, like when you learn like how to detect suspicious activity, is that very unique to that customer, or do you take and learn like ways of detecting things that apply to across the board?
So it's, to answer the first part of your question, it's a global label data set. There are some ways that we're kind of considering thinking about breaking it down, but probably not on a customer by customer basis. First of all, it's just not that much data from a single customer. But there are sort of different classes. There's children's hospitals, there's smaller clinics, there's large academic institutions. And within that kind of grouping, things are pretty similar actually across institutions, but there could be some differences. The other main difference is just which EHR solution, so which like electronic health record solution the customer uses. So those can have some significant differences in sort of the granularity of the activity that they track, the amount of data that we can get out of it. But we're still able to sort of run the same analytics regardless through our ETL process that normalizes all of this data and puts it into our schemas.
So, I mean, do you have to deal with a lot of data normalization? I'm just not familiar. Like, is there standards in your field or?
So as a company, we have to deal with a lot of data normalization. Yeah, so, and some of that, most of that, we really try to handle it upstream of our analytics applications.
Okay.
Yeah.
And then is there, I mean, would there have been a case instead of just saying no case or case to have something that maybe labels it a little more granular? The question basically said perhaps something between no case and something very egregious. Sorry, like maybe like a spectrum or anything.
Yeah. So so that's kind of what I'll talk about in part 2. So what we do is we give every access a score, but we don't necessarily say with this score this is definitely a violation or definitely not a violation. But if the customers want to say, give me 5 coworker cases per week, we can give them the top 5, and they can sort of calibrate that to the level that is giving them like what they're looking for.
Okay. I had one last question. I'll let you go to the next section just because it touches your second bullet. So like, this is very similar, I guess, like what happens with like malicious activity in cybersecurity, and people are looking for threats. But in that case, usually the actors are responding to the detection and they're trying to modifying their behavior. Are you seeing the same thing? Like if people are accessing these records and they're not supposed to be, do you find they change their behavior? Do they evolve and realize that they're being watched and then try to do things to skirt it?
I think there is some amount of that as well. There are some people that will kind of come up with kind of tricky ways of accessing something that will make it look like it's normal. It's maybe a little bit to a lesser extent. And in this case, a lot of it is people who maybe don't have really bad intentions. So they might not really be trying to hide it, but they are just misusing the data.
That makes sense. Okay.
Yeah,
I'll let you continue.
There's definitely a range though. There's definitely some that are quite difficult
Okay.
and quite interesting to see what people are doing.
Yeah. Okay.
All right, so yeah, so moving into part 2, which is how we use machine learning to prioritize the most suspicious employee behavior for our privacy compliance customers. Going back to the original product vision, we wanted to generate a score to rank all of the accesses. So I've been sort of alluding to the fact that we get this score from our classifier, but now I'll do a little bit more of a deeper dive into what this score is exactly. So we use scikit-learn for classifier training. And in addition to prediction methods, which offer a binary or multi-class output, a good number of algorithms in scikit-learn actually offer a method for generating a probability estimate for each data point. So on the right is a list of algorithms with implementation of this predict proba method, which includes logistic regression, ensemble methods, naive Bayes, neural networks, and support vector machines, to name a few. And all of these have some capacity to provide a probability estimate prediction, which is a slightly different algorithm, well, very different algorithm depending on which machine learning algorithm that you're using. So just to give you a really brief example of what this looks like, here's some code that you can use to generate estimated probabilities for all points in a test data set. So what I'm showing here is first a list of parameters for random forest classifier that maybe we've found as best parameters from our hyperparameter tuning. We train a random forest classifier using those parameters on our training data set, and then we score our test set, but instead of using the predict method, we're using the predict proba method, and one of the outputs of this method is for each data point, the probability of having, the estimated probability of having a positive label. So it's very important to note at this point that the predict proba method does not actually output a true probability. Each method, as I said, is implemented in a different way, and it also may be susceptible to changes in the label data set or in the tuning of the classifier. So if you are looking for a true probability, there's some additional methods that you can apply to your results to get closer to a true probability. For example, there's a lot of good resources in the calibration module in scikit-learn. And this is just a visual pulled straight off of this scikit-learn page, which kind of gives you an idea of the sort of problems you can run into if you're interpreting the estimated probability as a true probability for a number of example classifiers. So what's plotted here on the x-axis is the predicted probability. And then on the y-axis, the actual fraction of positive labels in that bin of predicted probability. And so if you had an estimated probability equal to your probability, you would expect to see the line x equals y, but in reality, you might not see that at all. However, when we're looking at estimated probability or true probability, the rank ordering of the data points remains the same. So for our purpose, we can actually just use the estimated probability to accomplish our goal, as long as we're just really careful about interpretation. So how does the predict proba method work? I'll explain how scikit-learn calculates the probability estimate for a random forest classifier. So we'll start with just reviewing the basics of random forest classifier. This is an ensemble method comprised of some number of decision trees, or called estimators. And each estimator is different or randomized because it's trained on a different subset of training data, and other parameters could also be set to control the randomization, such as the number of features to consider per split, min and max leap sizes, and so on. And so in this example random forest classifier, there are 3 estimators. And in the first estimator, the third leaf associated with a label of 1, the second estimate, or the first leaf is associated with a label of 1, and the last leaf is associated with a label of 1. Once this classifier is trained, then new data points are evaluated the following way. So say a new data point comes in associated with certain feature values, and then those values cause this data point to take the following trajectories to each of the estimators. And estimator 1 and 2 both assign this data point a label of 1, and estimator 3 assigns it a label of 0. So the final output is just the most frequent value from the individual estimators. So this data point gets an overall label of 1. But each leaf in the estimator is not just associated with a label, it's also associated with a proportion. And that proportion is the number of positive labels in the training data set that ended up in each leaf of the tree from over all of the total data points in that tree. So in estimator 1, the first leaf had 1% positive labels after training, second leaf had 4%, third leaf had 67%, and so on. So if we take our sample data point again, this time each leaf also provides a proportion estimate of the probability of having a positive label based on the single estimator. And the way that the random forest predict proba function works is by taking all of these proportions from the individual estimates and taking the mean of those values. And this is the final estimated probability. And this is what we use and what we refer to as the classifier score. So as I mentioned before, we use the score to prioritize cases to send to the customer, and the mechanism looks something like this. So if we have accesses from the last week that have the following scores on each day, if the customer wants to see 3 cases, then we can quickly go back and just find the 3 highest scoring accesses in the last week and create those cases in our user interface. And then we create the case, and it shows up looking in our user interface something like this with the score associated, which we service as the suspicion score. And this allows the end user to get a sense of sort of the relative confidence in the case compared to the other cases we've created. But we also provide the score on every axis. So for example, if the compliance officer is following up on this case and they look at all of the activity by Riley Grant and they're saying, wow, this is a pretty egregious violation, I'm worried about what else this employee might have been up to, then they can easily go in, view all of Riley's scored activity, and that allows them to quickly zoom in on other possible violations, which may not have become a case for whatever reason. And then finally, you might be wondering what the score looks like or how it behaves on our data. So here's a normalized histogram of scores on some sample training data. And what you can see here is that our positively labeled data actually has a very wide range of scores, while our negatively labeled data is super concentrated at very low scores. This might seem surprising at first, but it actually makes a lot of sense given the nature of the problem. So we have a very unbalanced data set. We have a huge number of negative labels and a small number of positive labels. So it actually means that the odds of having a leaf in a decision tree with a tiny proportion of positive labels or no positive labels is fairly high. And on the flip side, the large range of scores on our positively labeled data set is a reflection of imbalanced classes and just the relative uncertainty involved in identifying violations. So intuitively, this means that we can say that a large number of accesses are not suspicious with very high confidence, but there's a lot more gray area involved when identifying violations. And we know that's something that's true. And that's why our system is a tool to be used by compliance teams, but not something we really want to use alone to make a final judgment on a big decision like whether or not an employee should be terminated. So in summary, there are a good number of out-of-the-box methods for estimating class probabilities. But you do have to be careful because estimated probability is not a true probability. But if your primary objective is like ours, which is to rank your data set, an estimated probability might be sufficient. So I'll just wrap up there, and I'll take any questions.
So there was a question. It wasn't really a technical question, but it was like, what are the most common reasons that you're seeing people violate these? Is it, you mentioned it earlier, like looking at coworkers, but is that basically the top thing?
So that's, we actually surface them in a variety of categories. So family members, coworkers, VIPs, and then generic suspicious activity. There's a huge number of reasons. It can range anywhere from curiosity, whether it's about someone you know, someone you've heard about, somebody who's recently been in the news for an accident and are receiving treatment, someone high profile, or someone famous, and rumors kind of go around the hospital. That can be really damaging, but rumors kind of go around, somebody's here and people go look. But it can also be things for way more malicious intent than just curiosity. There's a huge amount of personal information, social security numbers, billing information, insurance information in people's records. So there's always questions of possible identity theft, or other kind of that sort of uses of the data. And even in times, we've seen cases where there's some sort of conflict going on between people and they're actually looking for data to use like in a lawsuit or something like that. And those are some pretty scary cases.
I think, and then before we got started, you mentioned that the company's around 80 folks. How big's the data science team? And then you had mentioned Spark. So like, what is your mixture? Do you have like pure data scientists? Do you have like software engineers, data engineers, or whatever you guys are calling them?
Yeah, so on our analytics teams, actually, we have a mix of data scientists. So there's actually only 3 data scientists and myself. And then there's about 7 data engineers or machine learning engineers that work with us on the implementation of the analytics product. So it's actually a pretty mixed team. A lot of the engineers get pretty involved in the research, and a lot of the data scientists are pretty comfortable doing software development. And so that's our analytics component. And then also sort of in our more platform side of the company, we have a lot more engineers who work on all of the problems of the transformation and the standardization of the data and ingesting the data from customers.
So so people are always interested, like how to get started and like what opportunities are in Maryland. That was part of what I was excited about. Like what kind of things does your company look for? I mean, are you guys looking for data scientists? what kind of skill sets do you usually look? Do you have any like suggestions for people that are interested in joining a company like Protenus?
Yeah, absolutely. So we're not hiring a data scientist at the moment, but we are expecting to in 2021. So I think we're expecting to put up posting for a probably fairly junior position. We're really looking for people who can really think carefully about the problem and think about the data. That's always going to be a bigger emphasis for us than their particular tools. All of us came in pretty comfortable with Python, scikit-learn, things like that. So that's always good to have in your toolkit. We didn't necessarily expect people to have a lot of experience with Spark, maybe a basic understanding of Spark. And we actually write our production code in Scala, and that's something that I think most of us learned on the job. So there's not an expectation that anyone's really an expert in that yet. But if you have some experience or if you've learned a little bit about it, it definitely doesn't hurt.
Do you expect folks to have, I mean, do you think you really need to have that background in healthcare and understanding that domain, or is that something where you can kind of learn on the job?
I would say that that's something you can learn on the job. So our data scientists, the backgrounds are, I did a PhD in neuroscience, and we have a physicist, we have a former astronomer, and we have a former evolutionary biologist. So none of us had that much experience in healthcare, but we have, on our customer success team, we have a lot of people who are former compliance officers, former healthcare employees that work directly with our customers. And we work really closely with them all of the time to get their feedback and their kind of domain expert opinion on the things that we're testing out.
Cool. And then one last question. Do you guys consider unsupervised techniques as well, or?
Yeah, so we're using those in some different capacities. Actually, if you check out our blog, I think there's a post about using hierarchical clustering in our drug diversion product and how we use that to identify peer groups among employees. So we're kind of incorporating some of those ideas in some different ways.
Cool. All right. Well, we'll pause right there so we can hand it over to Shelly, and then if anyone has any questions for the end, if we have some time, I can go back and forth between you. So Shelly, you should be co-host. You'll to share your screen and take over. And nice job, Ellen. Thank you.
Thanks a lot, Jason.
We see your screen, but you're muted, Shelly.
All right, can you see what I'm seeing? Yes.
Yes.
Okay. All right. Well, thanks for inviting me. What I'd like to do is sort of give you a little bit of background on the company and who we are, and then walk you through sort of some things that are out on the web that we do. So just to get started, so Yet Analytics, we're a company, small company set up in Baltimore. All of us work here in Baltimore. And we work in a space referred to as learning experience technology, both building commercial enterprise products, providing R&D to government and large organizations, and handling a lot of infrastructure related data services for those customers. We're based in Baltimore, and that's a whole bunch of words about us. We primarily work in defense, and there's a reason for that, which I'll get to in a moment. We've worked in industry, particularly in cybersecurity training, some work in the broadcast industry and in virtual reality. And then third, we have a presence in global education, particularly in West Africa. But on the defense side, part of the reason why that's frankly like 90% of our business is because the DoD represents the largest learning and training organization on the planet, and it is the most distributed learning and training organization with services and agencies covering millions of people across the globe. And so the training that they push to these people both has to handle issues of scale, handle issues of synchronicity and asynchronicity, and handle situations of multi-platform, multi-data source, both screen and post-screen synthetic technologies. So a very wide range, very high throughput, very high scale, and very sort of just complicated organizationally. The products that we provide help with a lot of the data flow for that type of organization. So what I'm going to do is I'm going to stop the screen share, or not the screen share, the slideshow, and start taking you through some of these projects actually online, so you can see. And a lot of the stuff that we do is open source. So if you want to get involved, get your feet wet, you're more than welcome to. I'll provide links later in the chat. So at the core of what we do in the space of learning experience is what is referred to as an LRS, or a learning record store. So the Department of Defense established a data specification for event-based activity data in the learning and training space. So you can think of it sort of loosely as like an activity stream in Facebook that has a certain vocabulary that allows you to capture data on what people like, what they comment on, what they post, what they share, for the purpose of, in their case, building a user profile to use as a data asset in advertising and product development purposes. What we do is we provide event-based activity data resources for the purposes of collecting data to improve and personalize learning and training to end users, and to provide the organizations with the information they need to make enterprise level decisions around work resourcing, content engagement and management, data flow, IT infrastructure, anything where data is flowing through the learning technology ecosystem in the enterprise. All of this work started within an R&D office under the Secretary of Defense called Advanced Distributed Learning. Advanced Distributed Learning started up, I guess, back in the end of the 90s, where it was tasked with providing specifications for the interoperability of learning management systems and e-learning publications that were being used across the services, particularly by the Army. Around the middle of the aughts, towards the end of the aughts, they began developing sort of the second generation of this series of specifications, which became known as the Experience API. And the goal here with the Experience API, which you can read more about, there are a ton of webinars, documentation, videos, all kinds of stuff. The idea behind it was essentially using an RDF type of semantic format of a triple of an actor, someone who does something, a verb, what they do, and an object or activity, what's being done, to start to classify events. The API then grew for the purpose of collecting a lot more information about those individual learning activities, and important to the project within the government was in the same way that the original sets of specifications at the end of the 90s were increasing the interoperability of LMSs and e-learning publications. Here, by the mid to late aughts, the goal was to improve data interoperability across any of the types of platforms that would be used in distributed learning environments, including learning management systems, e-learning via mobile apps, simulated virtual and augmented reality, and various forms of synthetic training environments, hybridizing virtual and biometric information. You can imagine, for instance, like someone who's learning to fly a fighter plane. They have sort of an ebook and a course that they go through. They have a real life simulator that they sit in and go through. They have desktop and mobile simulators that test and quiz them on different things. All of those different data sources together become sort of like the vectors of experience of that person, which is what we're trying to capture so that we can turn around and send better, more targeted, detailed, granular information and experiences back to the end user, and we can provide the people up top, managers, trainers, executives, generals, whatever, with the kind of information that they need to advance the enterprise. So ADL published the XAPI specification, which you can access on GitHub. It's just at GitHub ADLnet /XAPI-spec. The spec is broken into 3 parts. First one tells you a little bit about what the Experience API is, sort of purposes, relation to RDF and semantic web technologies. The second provides examples of what it looks like in JSON format. And the third details the sort of communications via API, data processing, validation, and security. When we go back to that initial sort of like central technology that we started with here at Yet, the purpose of the LRS is not just to act as like a database for the information passing through the system, but most importantly, while it does serve storage, retrieval, access, the most important thing is that it validates the data prior to allowing it in. So it's highly strictly conformant, requires highly strictly conformant data that's conformant to the spec. That data is allowed in, meaning that when you're pulling information out of the LRS, you always know the data model that you're working with. It's always spec, which obviously is a big deal. Part of the reason why someone like DoD would do that is the ability to just cut down on cost and technical debt by using common specification. So the spec is there. The spec, one of the things that it took from RDF was this idea of the verbs. The verbs in XAPI are completely flexible. So you can create new contexts using verbs to account for basically any human experience that results in a digital footprint. That sounds great, but in fact, it can be very unwieldy. Classic example in the space is if I'm training a basketball team and I'm training an infantry squad, there's going to be a big difference between when I'm saying what one group did when they shot something versus the other group. That semantic disambiguation is done through what we call XAPI profiles, again, published by the government on GitHub. It's all this stuff is Apache 2.0, so you're welcome to go grab it and play around. What profiles do is they allow you, A, to sort of model the domain in the sense of here are all of the possible activities that someone could engage with in a particular training, for example. And for that reason, when I model training for the infantry, I'm going to model something. I'm going to have a verb in my registry for shoot that means something different than when I'm training my basketball team. Additionally, XAPI profiles provides the ability to establish patterns, templates, and sequences of activity, individual statements broken down into these discrete forms, which allows you then to model, in this case, learning and training activity up against both sort of the business process models that training is aligned to, as well as the metric outcomes, allowing something like automation actually tied directly back to that event-based activity. Again, all following the same spec. All of this work, so it started within the DoD. It has been expanded out into, taken on by the IEEE. The IEEE is the largest technical professional association on the planet, and the LTSC is the Learning Technology Standards Committee within the organization that is tasked with creating global standards for all kinds of data and technology that touches the learning and training space. So part of my job is working very closely with my colleagues at the LTSC. I'm an officer at the LTSC, and I chair several of the standards activities related to XAPI. If you are interested in the standards side of the data work, it's all under 9274 at IEEE. If you're not familiar with IEEE, everything basically gets a 4-digit number, and all the standards activity happens within and under that number. 9274 is for XAPI, includes the base standard as well as the profile standard, which is currently starting development now. So if you're interested in semantic technologies and learning, now is a great time to get involved. It's a volunteer effort that's open to the public. I lead 2 groups on recommended practice standards, one for technical implementation and the other one for cybersecurity of learning technologies that contain XAPI. And then for individuals who want to make public profiles that they build for example, different business cases like in aviation or medical training, et cetera, they are able to come to the IEEE, suggest building profiles specifically for that industry or business use case. I also work with adaptive instructional systems. These are systems that leverage AI for the purpose of adapting the delivery and assessment of content via intelligent tutors with end users, and facilitating masses of end users with individual or small groups of instructors. Adaptive instructional systems often will use event-based technologies like XAPI in order to manage that data. I particularly am working here. We're actually just starting up a new group on ethics related to the considerations of ethics for AI in learning and training systems, broadly classified as adaptive instructional systems. Again, if you're interested in ethics and AI and the learning space, get in touch with me, and I'd be happy to help you join the volunteer group. Now, what you're looking at here, just to sort of drill down to the type of data that you can get, this is, I'll blow this up a little bit. This is just a dashboard that is showing us the type of data that is sitting inside of our XAPI LRS. You can see I have things like total number of statements, how many training activities I'm tracking. The tracking can be micro or macro. In this case, 4 activities could be something like checking that someone did something for 4 instances within a task. It could also be 4 separate systems, for example. Looking at things like what and when things are happening over time, hotspots of activity over time, who is active, when and how, what variety of experiences people have. Again, this is all sort of high-level administrative information used to basically check the health of the LRS. Within individual statements of data, we can look at the actor, the verb, the object. Objects themselves come in several types, including interaction types for training experiences. So true, false, matching, sequencing, Likert, etc. I can set the system to automatically track according to the type of assessment that's being given. Context, we can track what platform is being used, who the instructor is, what team the person, the end user is on, what language they're working with, all the international standard languages. We can look at things like the type of interaction. I'm getting overwhelmed just looking at this. Look at things like the authority of where it comes from and results. So things like, was the person successful completing the activity? Did they complete the whole thing or not? In terms of scaled or raw scores, where were they? What was the duration of bits of their activity over time? For instance, if we're tracking how someone is watching a video while they're doing a video course, we can look at how long are they watching something before they pause it? Where do they fast forward to? Where do they back it up? Where do they decide to pop out and go to something else on the browser or share the information? The individual information itself is all captured as JSON in a standardized format. It's showing us the actor, in this case, someone captured by their email address. The verb, what it is that they're doing. This verb points back to a authoritative profile, so I know exactly what the verb means, and it points back to an IRI or a URI, yeah, for the verb. The object, what it is that they're working with, and then information about the object, some context, provides me the types of extensions of what it is that we're capturing, like did they complete, did they pass, did they fail, etc. The information from there, so what you're looking at here is just administrative information, just check that your LRS is working. From there, that opens up sort of like a whole can of worms in terms of product development and product ecosystem. So we built out an open source data visualization environment for the DoD. It's called DAVE, Data Analytics Visualization Environment. Again, it's Apache 2.0. You can go in and use it. There's information about here, some webinars and things. You can check it out. Basically, what it looks like is, I can't get that darn thing out of the way. There. It's over on GitHub. It provides you with, it's in beta currently, it provides you with The analysis tool, it transforms XAPI for you using a query language that we built specifically for XAPI. It provides a visualization spec based on the visualization grammar provided by Vega up at MIT. And you can save and do stuff with workbooks. So this is what it, I'll come back to that. This is what it looks like. I have an analysis. Within the analysis, you've all seen this type of thing before in like a Gorilla repo or something like this. We have a query editor. You can put in your query. We have a couple that are set up in template. When I run my query, what I'm doing here is I am running both a custom query that's written to XAPI, as well as the visualization spec, which is in Vega. The spec is portable, so I can export this and run it out onto any other system that I wanted to. Part of the reason why we did this for DoD is because they weren't happy with the fact that like there are things out there, of course. If you run Mongo, you can use sort of visualization engine to run visualizations off your Mongo database. But then if you want to switch out and not use Mongo, you're hosed. So what they wanted was something that was completely agnostic in terms of platform usage. So you can run it on anything. We built it in Clojure with Clojure script front end, runs off the Java machine, etc. The second thing is, now that you have all this data and you have ways to query it and visualize it, how do you actually test that your systems can deal with it? We're talking about large scale systems. So we built out a data simulation application for the DoD. Again, you can go in and see the documents and whatnot. There's a technical report that is available online through ADL. Basically what it does is it walks you through the project. The project itself, it provides inputs and validation. So you provide an XAPI profile, and then you choose to add certain variables to the profile, including personae. This is who your actors are. Currently, simple stuff like their location, their mailbox, future things, things like aligned to psychological profiles. Alignments sort of influencing either implicitly or explicitly how likely individuals within our simulation are going to do certain types of tasks. You can sort of put your finger on the scale to test things. The simulation parameters themselves, like how long does this thing work? Is it a simulation that occurs? Are we simulating 5 minutes of time? Are we simulating sort of a 10-year longitudinal study? And then motivations for the actors themselves. The end result is a production of a data set that's aligned to that profile. So it models whatever it is that, or it rather expresses the data of whatever it is that you've modeled as the learning and training activity. And it's being used for testing and evaluation of the systems that have to use and put this data through. So for instance, if we need something that can handle 1 billion statements a day and be able to validate the data and know when to send certain data up to a credentialing system or whatever, you can test and evaluate that in a simulated way using DataSim. So you can see more about everything that we're doing over at the website, yetanalytics.com. Includes some upcoming projects and work that we're doing, including a new learning experience platform for the Air Force that is built on all of the technologies that I just showed you, plus the ability to pull content from the web or CMSs to allow this sort of like total tracking environment for the purpose of personalizing training, improving speed, accuracy, and handling these things in a distributed manner at scale. So I'll stop there and happy to answer any questions.
So I was curious, like, what are some of the data science and AI machine learning problems that you're facing? It looks like you have like a complete ecosystem of getting the data, storing the data, visualizing the data, working with the data. So what kind of data science related things are you looking at?
Right now, some of the more interesting things are around profiling uh, non-screen training behavior. So within the Army, they're doing R&D on what's referred to as the synthetic training environment, which includes things like complete total immersive training with biometrics, physical, um, virtual reality, augmented reality, everything, sort of all inputs. And one of the real challenges is integrating data from across those sources. Um, and a lot of the work that we do is on identifying which pieces of activity data will be beneficial to a profile of who it is that we're training. So that's a big part of it. There's a lot of profiling and modeling. And then the second part is how sort of at speed, at scale, and automatically do you take the information that you're getting from the systems and you're able to identify competencies for the purpose of credentialing people. So there's a lot of work done. Here is, for example, a competency framework that the Army has for these are all the things and these are all the levels, like think like like a game. Here are all the levels as you move towards demonstration of proficiency to move to the next level. How do you do that in a way that is sort of self-regulated by the system itself? That's a lot of the work that we do. Obviously, that involves a lot of systems. Our part of it is that middle part, sort of collecting, validating, profiling, modeling, and then moving the data to the automated systems that are going to use it.
What, can you talk a little bit about the tech stack that you're using? Like what, what technologies and things? Yeah.
We're entirely a Clojure stack. We use Clojure for immutability. The specification itself in DoD calls for immutability. Likewise, we do front ends in Clojure script. An advantage there is sort of Clojure is a Lisp dialect. So you have sort of like this old idea of like all data is code and all code is data, which aligns well to a lot of sort of the inputs and outputs in systems where essentially you're trying to make things machine readable and send them up to automation systems.
Have you had success finding engineers with that experience?
Yes, but it's with qualification in that compared to Java engineers, we have nowhere near the pool to grab from. But what we have found is that because of the types of challenges that we deal with, a lot of engineers who are doing Clojure actually want to work with this stuff. So we've never had a problem getting people up to this point. We also run a very lean company. There are less than a dozen of us working entirely from technical standards and concept where I live through engineering, data engineering, software development, and integrations specialists. And then we team with other groups who do a specific AI technology or a specific content authoring technology or whatever. And we found that approach of sort of like teaming. Just as a technical organization, we like it because we don't have to spend as much time, giving people a bunch of marketing bullshit because everyone understands what we're talking about.
Yeah. Can you talk a little about like, so one thing I would like folks to take away is like potentially ideas of how they could get started, with their own company or ideas. And can you talk a little bit about how your company operates and like how you get started? And the reason I'm asking is you have so much stuff that's open source, right? So it's like you're very willing to share stuff, and even your visualization tools, a lot of things that you built up And then I saw a reference to SBIR that you used that. So I was trying to understand like how did you get started? Like how do you work with that open source community? Like provide like how does your business make money? I guess I mean, I don't know how else to ask it, things like that.
Sure. The open source, there's a big difference between open source and free. You make money because you are working within a community. People respect your expertise within that community. People use the products that you build, and people want new capabilities built off of those products. That's how all the work has come to us. We want to be open, honest, and sort of, good brokers of good engineering. And we found that attracts business. Where we got started, we actually, we were working on a project back in 2013. We ran into a roadblock in the problem that had to do with data interoperability across mobile systems. And we were introduced to this office at the DoD because of the interoperability specs that they were working on. Very quickly, we found a lot of common ground and we started building out within the open source community sponsored by the DoD. A lot of people don't realize that the DoD actually puts a lot of R&D effort into open source. And then secondly, working then for building products and pushing those products both into the government and into the commercial sector. I would say that if someone is interested right now and you're based in Maryland, I would strongly recommend looking at all the opportunities that come through AFWorks, which is the Air Force Innovation Fund. It is their sort of, it's sort of like if the Air Force were a VC firm and all of their money comes out of the small business research space. They can provide significant seed funding, like early stages, like $1.5 million to get started on your way. And they are putting out now, I think they're putting out challenges like quarterly or at least twice a year. So there's no reason not to get involved.
Cool. Yeah, I'm gonna have to look at that. I've heard of that a little bit, and I think that's a untapped, resource that some people miss, like the whole SBIRs and the AFWorks and the challenges that are coming out of the government and some of the money. So actually, that leads into a question I had for both of you. You guys are probably a little closer to some of the non-defense work also. I mean, you're doing defense, Shelly, but you guys are probably a little more involved in the community through TEDCO and other things. Do you guys have any recommendations for folks that are trying to get more involved in the local data science community or analytic community, are interested in building businesses in Maryland, like resources they should tap out or look at? Shelly, you can go first, and then Ellen after that.
Yeah. So you can tell based on the presentation that I'm sort of biased on this, but I would say that if you want to get involved, do open source, get involved in the community, think wider than Maryland, and then demonstrate who's using and building on your source and within your community as some verification. It's a form of customer verification that people like the project, and a good way to think about starting up, putting together a pitch to get some funding.
Ellen, did you have any thoughts?
Yeah, I mean, I guess I personally don't have a lot of expertise in actually building up the company and being that sort of person to go out and advocate for it. But I definitely agree with what Shelly says about contributing in open source communities. We've had a lot of people that have come to us and been able to show some great work in that kind of area. And it's always cool to have somebody that's really connected into a particular community. So that, and things like this, and it's kind of hard to make as many connections and do as much chatting online, but definitely reach out if there's something that you're interested in.
Yeah, I mean, one thing that I'm noticing between both your companies is the reliance on feedback, right? I mean, I think you both have it different ways, but it seems like very critical to the success of your companies. You guys were able to build something, and you did it through the open source, Shelly, and then you got feedback and you know what to build. And then Proteus, you were mentioning some of the feedback you're getting from your customers to build additional features and detecting certain things. So that seems like a key thing, like finding that niche. Um, I guess, like, do you guys have any parting thoughts that anybody should take away, like actions or things that you would suggest folks do? We always get questions about getting started, like where are people hiring, the normal things. If you guys have any recommendations or anything, that would be appreciated.
Yeah, on the starting out thing, I would say that the most frustrating thing that you'll hear over and over again is that you're too early. But that's not the worst thing that you'll ever hear. The worst thing that you'll ever hear is not hearing the word no. And you will waste a lot of precious time and resources in chasing money and other things from people who won't come out and say no. Get to a yes or no. And if they can't say no to you, walk away and let them chase you.
How about you, Ellen?
Yeah, I mean, I guess I can sort of make a plug for the route that I came through, which was that, I did a PhD in hard sciences field, and then I wanted to go into data science. So I took advantage of a boot camp called Data Incubator, one of now many options and options to do these boot camps in person or online and get some experience, but also get introduced to some young companies that are looking for data scientists. So there's a lot of options like that. And then I'd say just starting out, if you find even a fledgling company that's getting started, if you really have that enthusiasm for the problem that they're working on or the tools that they're using, that can really go a long way.
Yeah, I mean, like you mentioned, you started a couple years ago and you grew with the company and you watched the company grow. So look, finding those opportunities, you can find companies that are going to grow and become very successful, and you can get a lot of experience. And especially if you find people that are willing, like you mentioned, you're willing to bring on folks sometimes that don't have that domain experience. So that's really good, right? And then Shelly recommended, the open source. So there's definitely ways to get involved, either through open source or finding avenues in where you may not have all that expertise. So I think that's some good advice. Well, with that, I mean, I think we're hitting the end, and I really appreciated both of you guys speaking about your companies and showing, some of the things that are going on in Maryland. There's a lot of interesting things outside the defense. Everyone always thinks about the defense and the government contractors, but there's a lot of stuff going on with healthcare and building data companies and working on open source and things like that. And I appreciate that you guys taking the time and talk to us. If you ever need anything, please let me know. And I appreciate everybody taking their time and attending the meetup. I hope to see you guys next month. A recording will be available. I record this, so if you guys ever want to look at it again. With that, I'll let everyone go. I mean, thank you, Ellen. Thank you, Shelly. Thank you very much. Hope everyone stays safe.
Thanks a lot, everyone.
Yeah. See you guys. Thank you. Good night.